So when you have saturated hydrocarbons, there's only two types of reactions you can do with them. One being a combustion reaction, you blow it up. The second being a free radical halogenation. Now, free radicals basically are atoms that have one extra electron. They don't have a charge, so they're not ions, but they have one extra electron, which is incredibly reactive. What you would use here is either going to be Br2, how do you do it, 2, or Cl2. Okay? The best way to think about it is simply that there's basically a bond between these two Brs, and each of these dots is an electron. Well, what happens is if you add heat or light, I don't remember which is which, but one of them reacts with heat, one reacts with light, you get what's called a homolytic cleavage. So one of the electrons from the bond goes to one bromine, and the other one goes to the other. Notice the mechanistic arrows only have one-sided arrowheads because it's only one electron, not two. And so what this gets you, let's just say, so with heat or light, it's going to get you 2 Brs that are just free radical bromines, or and so these are incredibly reactive, and of course this whole thing can go for chlorine as well. It won't go for fluorine, and iodine doesn't have enough energy actually in the system to do that. So it's really only bromine and chlorine. So this plus, let's just say this. So this is of course C3H8. C3H8. As far as you don't know, this is C with 3 H's, C with 2 H's, and C with 3 H's. So what happens is, let's just look at one of the hydrogens that's coming off this top here, okay? Again, the bond here is basically 2 electrons. Well, one of the electrons comes over here and gets bonded with the bromine. Or, well, from the hydrogen. The other electron goes back down to the hydrocarbon. So what you end up getting is HBr plus a free radical hydrocarbon. Now, this free radical hydrocarbon, when put in the presence of more Br2, because there's going to be a lot of it, will again cause the same homolytic cleavage that we saw up here, and end up forming a radical bromine plus a halogenated hydrocarbon, because the bromine basically went on to where the the radical was. This is very important. You can do a lot of different reactions with this based on, substitutions or eliminations or, all sorts of things. Now, I hope to make videos on those as well. One thing to note, however, is on this particular example, both of these carbons here on the ends are primary. They're only bonded to one other carbon. However, this one is bonded to 2 other carbons. It is a secondary. If we were to take an example, however, well, it's actually a bad example. In this scenario, this is a tertiary. The hydrogen is most likely to come off the most substituted carbon. So the tertiary is much more likely to give off a hydrogen than the secondary, which is much more likely to give it off than a primary. So the only time when you're going to have a primary free radical halogenation is if you just had like C2H6, you know, just a line basically. That's why it went to the secondary carbon, and in this case it would go to the primary. Now this one, if you notice, this is a I guess quaternary hydrogen or carbon, has 4 carbons attached to it. However, it doesn't have any hydrogen, so be careful not to try to halogenate it because it won't work. There's nothing to substitute because it won't substitute a carbon. It has to have a hydrogen on it. You know, because this one has 1, this one has 2, and whatnot. So I hope that helps. Enjoy.